Hi everyone, this is Santosh Kumar. Welcome to NX training. Today we are going to continue explore the model workbench. So imagine there is a cutout like this and you need to fill this particular cut. In that case you can make use of this through curve mesh. This is a very handy tool. So once you select this through curve mesh, it will allow you to select primary curves. First you need to select the primary curves, later you have to select the cross curve. I am going to select these two primary curves and select the middle mouse button. Again select this. So you can selected the two edges of the primary curves, and then next you need to select the cross curve. This would be my cross curve. Again middle mouse button, press the middle mouse button and then select the, you're going to get the surface. So that's the use of this through curve mesh. But as you could see here, this particular surface whatever you created, it's not tangent to the parent body or the parent surface. As you can see, it's not continuously following that particular path. Instead it is just trying to cover up or creating a patch kind of thing, but you still want this surface to be tangent to these neighboring surfaces. In that case, if you go here below, you have something called as continuity. The continuity, if you see, first primary continuity, that is G0, G1 and G2. G0 stand for just a point. You just want that particular surface to connect to the neighboring surface. That time it will be a default G0 positioning. But you want it to be a tangent to the neighboring surfaces, then you go for G1 tangency. So once you give a G1 tangency, and you need to select that particular face. I want this face, I want this face to be tangent and continuously followed onto this surface as well. Then I'll be selecting that face. Again this last primary curve, I'll give it as a G1 tangency and I'll be selecting this. Then first cross curve. So again I want tangent even in the if you consider this to be the horizontal and this to be vertical, from the vertical as well I need the tangency to be followed. In that case I'll be selecting the surface. Again the last one as well, I'll be selecting the parent surface. So once I select this, as you could see, now the end results would be different. This surface will be tangent to all the neighboring surfaces. So that's the use of the continuity. So that's what this G0, G1 and G2 stands for. G0 is for position, G1 is for tangents, and G2 is for the curvature. If imagine the parent surface curvature has to be followed by the surface which you are going to create, then you can change it to G2 continuity curvature. So these options are available under the continuity. Next we are going to look into the through curve. In through curve you have select curve or a point. Middle mouse button, select, you're going to get a through curve just by selecting two sections. So once again here you can give this whether you want to be a tangency continuity, and here also do you want it to be a tangent continuity. So this is just by selecting two curves you'll be able to create the profile. So in the through curve you even have the alignment, so you can preserve the shape and you have other alignment options in the drop down. Accordingly you can change according to your requirement. Next we are going to look about the swept option. So select curve, I'm going to select this as the curve, and next I'm going to select the guide. You can give maximum of 3 guides, so if there are 3 guides it will try to follow all those 3 guides. So I select this as my guide. As you can see, this particular profile is trying to follow this guide. So imagine I created a profile like this. Now I'm going to use the swept option and to select the section, and I'm going to select the guide. So this is my first guide, and I'm going to click on this add. I'm going to select my second guide. As you could see, it is going to sweep that particular cross section across these guides which I selected. So this way you can create a profiles with the help of the swept option. So next we'll look into the fill surface. The fill surface, it is asking to select a boundary, so I'm going to select a boundary like this. So it just create a patch near the surface with a G1 continuity, and here you have several methods. Default it will be none. You can select according to your requirement. You select the fullness, you get another control point offset, so you can offset this value. Once you offset this value to a set value, it would kind of create a patch. So that's the use of the fill surface. So next we'll look into the trim sheet. The use of this trim sheet is, there is a surface like this and there is a line over here. I want this particular sheet to be trimmed. In that case I would be using this trim sheet. Select that particular body and select the boundary object. This is my boundary object, and I want it to be trimmed normal to the surface. You want to keep that particular region or discard that region, accordingly you can choose, and you can see the preview. See, as you can see, it's keeping the main parent and it's discarding the uh, surface that you don't want, or you want to discard it. It would discard the parent one and it will try to retain the other. Here you have even the vector. How do you want the trim sheet to happen? Now if you see, the cross section is over in a different plane, but the surface is somewhere ahead of that particular profile. Now I want this rectangular cutout to happen over the surface. That time I can make use of this trim sheet, the trim sheet, and select this body or the surface and select the body. As you can see here, it is by default trying to take the normal to this particular surface, but I don't want it to go in this direction. I want to go vertically up. Then you can change this to a vector and select that particular vector, so it will show you a preview where exactly the trimming is going to happen, and then click on OK. It would try to give a cutout like this. So that's the use of this trim sheet. And the next one is bounded plane. Bounded plane would be applicable only on flat and profiles. So you cannot apply the bounded plane onto this curved surfaces. It won't allow you to create a bounded plane here. See, it's not allowing you to. It's saying string objects not coplanar. So it will create only if you have a coplanar surfaces. Upon the surface only you can create. For example, so this, if you see this particular sketch, whatever I created here is a coplanar. It is in the y-x plane. So now here it will allow you to create those profiles. So bounded plane, and once I select this boundary, see, it's creating that plane. So that's the use of the bounded plane. It's trying to create a plane. As you can see here, two planes are being created. So that's the use of bounded plane. Next we'll see the sweep along guide, and select the curve, that is the section curve, and next the guide. So you can even provide an offset in this. So as you can see, a 1 mm offset has been created. So it would be something like this. The profile would look something like this. So next we'll see the thicken. I'm going to extrude the surface. Now I want to give thickness to this surface. I would select the thicken and select the surface, and I will specify the thickness value, and you will get the thickness. So that's the use of thicken. Next we'll see trim sheets that we have seen already. Next we'll see the extend sheet. I want to extend this particular sheet further, then I will be making use of this extend sheet. Select the edge that I want to extend, and I specify the value, how much you want it, the value to be, like say for example 30. So it will be extended to 30 mm. Next we'll see the tube command. So I want to convert this particular spline into a tube. Then I will select the tube command, select the curve, select the outer diameter 10 mm or 1 mm, click OK. So you get a tube over that particular curve. You don't want this to be broken into multiple segments. In that case you can double click it. You can change in the setting from multiple segment to single segment. You'll get a smooth profile like this. Now I don't want it to be a solid entity like this. I want to be like a straw kind of a thing. In that case, you can specify the uh, inner diameter as well. So the inner diameter will be 1 and the outer diameter is 2. So you'll get a tube kind of a thing. Next, offset surface. So there's a surface like this and you want to offset this surface a certain value. You can make use of this offset surface, select the surface, and then you can specify the offset value. So the particular surface would get offsetted to that value. So that's the use of the offset surface. So next we'll look into the trim and extend. Imagine there is a surfaces like this which has been extended out. You can make use of this trim and extend until selected. Select the face. So I want this face, and this is the tool which is going to. So as you can see here, this face is been trimmed until this tool. So that's the use of this trim and extend. So once I click on preview, it would trim that particular sheet to till that reference boundary sheet. Next, I don't want it to be trimmed on one direction. I want to be trimmed on either direction. Create a corner kind of a thing. Then I would change this to make corner. So if you see, both the sheets have been trimmed and it's forming a corner. So this is how the end results are. That's the use of trim and extend. And you can even retain or delete the arrow side. They're even giving you. So if you select this delete, the other surface would get deleted and the upper counter one would get retained. And if you select retain, the one against the arrow would get deleted and the one towards the arrow would be retained. So that's the use of trim and extend. So next we'll look into the reverse normal. The reverse normal would reverse the normals of a particular sheet. Say for example I select this sheet, it is pointing towards the left, and I select these sheets, it is pointing towards the right. The moment I click apply, the vector direction is being reversed. So that's the use of this reverse normal. So that if I apply the thickness, it would try to take in the outward direction. But with now imagine I am going to remove this reverse direction, and now I am going to give the thickness, it is taking inward. So this is the use of the reverse normal tool. Reverse normal command is used for the purpose. So if you like this video, hit the like button and share max. So in the next video I'll be showing you a couple of examples of how to do a feature based modeling. Until then, bye. Santosh Kumar signing off.